Hello, Matthews Gatos here. Welcome to Irrational Numbers. Let's get started. Irrational numbers belong to the real number system. So let's review all the parts of that. So we're going to start small and we're going to start to build our way up. So we start first when we learned about numbers with natural numbers, and those are the set of positive counting numbers. So those are when you wanted to count something, you would just start with 1, 2, 3, 4, etc. No decimals, no fractions, no negatives, no zero. The very basic number system, natural numbers denoted by an N. Then we learned about this number 0, and so adding 0 to the natural numbers created another number system called whole numbers. Now, whole numbers are the set of natural numbers plus the number 0. So that's 0, 1, 2, 3, 4. But again, no negatives, no fractions, no decimals. We denote whole numbers with the letter W. Then the next number system we learned about was integers. That's where we introduced negative values. So integers are the set of positive and negative whole numbers. So that could be -3, -2, -1, 0, 1, 2, 3, continuing infinitely in both directions. But notice we have no fractions, no decimals, just positive and negative numbers with 0. We denote integers with the letter I. Then came rationals. This is where we start to introduce fractions and decimals. So rational numbers are any number that can be written as a fraction, a over b, where b is not 0. Now, it's important to note that I can write an integer as a rational number, for example, -3, just by putting it over 1. I can write a whole number as a fraction, say 2 over 1. And I can write a natural number as well as a fraction, we'll say 3 over 1. I could even write 0 as a fraction, 0 over 1. So rational numbers are all numbers that can be written as a fraction. Even decimals, repeating decimals, terminating decimals, those can be written as fractions. We denote rationals with the letter Q. Why on earth would I use Q? Well, because R is taken by real numbers, which I'll get to in a minute. Then we have this number system, which is all by itself. It's off on the side. It stands alone. This is the set of numbers, irrational numbers, that cannot be written as a fraction. So we denote that with a Q and a line over top of it. Now that line over top of it is not. So this symbol literally means not rational. So irrational numbers include non-terminating, non-repeating decimals, pi, the square root of a non-perfect square, the cube root of a non-perfect square, etc. So you put all of this together and you get the real numbers. So the real number system is the set of rational and irrational numbers put together, and we denote that, here's our R, with an R for real numbers. So let's look pictorially at what the real number system looks like all together. So this beautiful bright diagram here. Right in the middle here, this blue system represents the natural numbers. So that's what we started with. And then we built. So the natural numbers plus the number 0 create the whole numbers. If I take all of the whole numbers, which also include the naturals, and I add negatives to that, I now have integers. If I take the integers, the wholes, and the naturals, and I add decimals and fractions, I now have another number system called the rationals. So see how these are all kind of stacked inside of each other? All by themselves over there are the irrational numbers. Those are my non-terminating, non-repeating decimals. But all together, they make up the real number system. So I love that picture showing just how everything is related. So let's try classifying some numbers. So for example, I have the cube root of -8, and I want to know if it's an element of which one of those numbers. Now, just so you know, that little e here actually means element or belonging to. So I'm really asking you, what number system does -8, the cube root of -8, belong to? Well, let's evaluate the cube root of -8. So I'm looking for -8 to break it down into 3 identical factors, which would be -2 times -2 times -2. And the cube root is one of those 2 identical factors. So the cube root of -8 really simplifies to be -2. So let's go through and see which one it belongs to. So it's not a natural number because naturals don't include negative, neither do wholes. It is an integer because it's a positive or negative whole number. It's a rational. I can write that as a fraction. I could say negative 2 over 1, or I could say negative 4 over 2, etc. If it's rational, you know it's not irrational. And all numbers that are rational or irrational are a real number. So it belongs to integers, rationals, and reals. Let's try another one. The square root of 9 over 64. Well, let's break that apart. I know I'm going to break that into the square root of 9 over the square root of 64. So the square root of 9 is 3. The square root of 64 is 8. So I end up with 3 over 8. So naturals do not include any fractions, neither do whole numbers, neither do integers. So because it's a fraction 3 over 8, I know it's rational, which means it can't be irrational. Numbers can't be rational and irrational at the same time. And because it's a rational number, I know it's a real number as well. Okay, last example here, let's do the square root of 27. So we did a video all about estimating square roots, and I know that is not a perfect square. That is in between the square root of 25 and the square root of 36, which means that number is in between 5 and 6, much closer to 25, so much closer to 5. So I know when we did these, we said that the square root of 27 is approximately, and then you could have 5.1, 5.2, 5.3, or 4, for example. Because I said it was approximately, it means that it is not a whole number, it is not a rational number. The square root of non-perfect numbers are actually irrational numbers because they don't terminate and they don't repeat. So I know this is irrational, which means it can't be any of these ones at all, but because it's irrational, it is also real. So this is just an introduction to some of the number systems. So I want to introduce you to the number 4. She's the wife of Pi, and they had some problems in their relationship, had to go to a counselor, and she says, Pi is so irrational. He just goes on and on and on. Get it? Because Pi is an irrational number. So if you like this video, please give it a thumbs up and hit subscribe. It helps me reach more mathies in need of help. Thanks for watching, and see you for the next one.